ezobuchwepheshe, i-computer applications technology, kanye namaklasi e-learner wellness, okungukuzilolonga ngokomqondo kanye nomzimba. Lezi zifundo zethulwa nsuku zonke kusukela ngoMsombuluko kuya ngoLwesihlanu, kuqala ngehora lesi-4 kuya kwelesihlanu, u-4 kuya ku-5 ntambama, nangomgqibelo kusukela ligamanxe ihora lesi-8, 8:30, kuze kugamanxe ihora lokuqala emini, 1. Zithameleni futhi lezi zifundo emsakazweni Ukhozi FM njalo ngoLwesine kusukela ngo-9 kuya ku-10 ebusuku. Ningangena ekhasini lethu lika-Facebook elithi Go Digital SA_movement noma kwi-YouTube uthi Go Digital SA Foundation. Siyethemba nizolijabulela lolu hlelo oluhlose ukunifundisa futhi lulekelele kulokho enikufunda ezikoleni zenu. Luthokozeleni ke lolu hlelo nimeme nabo bonke abanye abafundi bebanga le-12 grade 12 ukuze nabo bazuze kulo futhi nonke nicijeleke ukuphumelela kwizivivinyo zenu zokuphela konyaka.
Sanibonani grade 12. Namhlanje sikhuluma paper 2, physical sciences, chemistry, and for so cover paper 1. So paper 2 into isele electrochemistry and fertilizers. So namhlanje sokhuluma electrochemistry. I-topic encane kodwa nje inama-marks amaningi and ilula futhi uthola lama-marks mawufika kwi-exam, but futhi i-topic ungakwazi ukuyi-understand kalula. Electrochemistry sikhuluma nge-application yaka grade 11. Grade 11 akhuluma nge-redox reaction. So a redox reaction, it's a reaction that involves the transfer of electrons. Redox reaction. So, a reaction that involves the transfer of electrons. And now when I grade 11, so one grade 12, so it's a application yakho. Now must come transfer of electrons, so you understand ukuthi ama-electrons asuka kwi-element eyodwa aya kwi-element esibili. But let's say for example element A siphinde sibe no-element B. That's just an example. Kusho ukuthi so ama-electrons azosuka la ku-A eze ngala ku-B. So A is losing ama-electrons while B is gaining ama-electrons. Ngoba sithi A is losing ama-electrons, sizothi A is oxidized. A is oxidized. Ngoba B is gaining ama-electrons, so B is reduced. B is reduced. Masithi is oxidized, A oxidized. Oxidizekile ngoba khona B. So B is the one that oxidizes A. Mesothi B now, B reduced. B is reduced because of A. Ngamanye amazwi ukuthi A wona reduce abani B. So A singambiza ngani nge-reducing agent. A reducing agent ngoba wona wenza B abe reducing agent. U-B ngoba u-reduced kodwa uya-oxidizer u-A, so u-B usingabiza ngani oxidizing, is a oxidizing agent, right? So kuma definition tofanele sithole ukuthi masikhuluma nge-redox reaction sikhuluma nge-reaction involve transfer of electrons. Now a substance that is losing electrons sithi is oxidized. A substance gain electrons sithi it is reduced. So ngamanye amazwi sothi ukuthi ku-A kwenzeka in oxidation. Kwenzeka i-oxidation, B kwenzeka i-reduction. I-reduction. Ilapho qhamuka khona igama elithi redox. That red for reduction, mase no ox for oxidation, mase kuphuma bani or redox reaction. So ngoba sinala magama u3 siyakwazi ukuwa define into eyodwa, siyakwazi ukuthi in oxidation, the oxidation is a process where electrons are lost. And reduction is when we have what? A gain of electrons. A reduced substance. The substance that is reduced is the substance that is gaining electrons, while the substance that is oxidized is the one that is losing electrons. A substance a reduced sibiza nge-oxidizing agent. Kusho i-definition yayifanele. So ungakhuluma nge-reduced agent sokhuluma nge-substance gaining electrons. Noma uyibiza nge-oxidizing agent. Noma uzothi kuleyo substance kwenzeka yini i-reduction. So the substance B is undergoing reduction, means B is reduced. B is called the oxidizing agent. I-oxidation enzeka ku-A, so A is oxidized. But A simbiza ngani nge-reducing agent. That's all you have to understand that. Now, into soyimona ukuthi masibuka nge in terms of electron transfer, sizo i-definition yethu izohamba ngaleyo ndlela ukuthi oxidation is when there is a loss of electrons, a reduction where there is a gain of electrons. There are many ways you can try to remember it, right? Kona makhuluma ngokuthi oil reduction is loss. That means oxidation is loss of electrons. Reduction is gain of electrons. Right? You can just remember that into no longer oil. Use food oil. When you know O goes for oxidation, L goes for lost. So say oxidation is the loss of electrons. Then obviously the rest, a gain of electrons. That one will be a reduction. Right? Now, uzobona ukuthi masikhuluma nge-substance lambe, let's say A in our example. Ukuthi initially A neutral. Masibuka hlambe start element ethize from a periodic table, right? To A. Once A has lost electrons, obviously sizoba ne charge. So to A, let's say A lose electron eyodwa, so it's gonna be what? A plus. Now, uzobona ukuthi from A, i-charge yakhona u0, and when it has lost electrons sekubani, seku-positive 1. So uyabona ukuthi le number leso ithola ingoba this element isingena bani kwi-compound. So le number so inika la kwi-charge sibiza ngani nge-oxidation number. So ibiza ngani i-oxidation number. Masibuka u-B. U-B bekhona kanje mhlambe oxidation number yakhe u0, just an example. After gaining sekunama electrons amaningi compare. Ngoba u-A ukhiphile electron eyodwa kusho ukuthi u-B uzoreceive eyodwa. So u-B will be a negative charge. So uyabona ukuthi isuka from 0 iye ku -1. And from our example sithe A is oxidized and u-B is reduced. So what can we say from here? Masibuka ngani? Masikhuluma oxidation number. So ngamanye amazwi singathi ukuthi oxidation in terms of oxidation number sothi oxidation takes place when the oxidation number increases. So a substance that is oxidized is the substance that increases in the oxidation number. The substance that decreases with oxidation number, then that substance is reduced. Ngoba sometimes bakutshela ukuthi define oxidation in terms of oxidation number. So maku reduced kusho ukuthi oxidation number iya decrease. Mabuti oxidized, the oxidation number here increases. So you can also define in terms of oxidation number. Normal would define in terms of electron transfer. Right, so that's what we have to do. Then, going to so half reaction. I-half reaction ngoba i-redox reaction ayenzeki like ungaba no A kuphela uzoluza ama-electrons. Makuthi u-A uluza ama-electrons, it means there's B esifanele athole bani lawo ma-electrons. So ingakho uzobona ukuthi ku-A kwenzeka i-oxidation kanti ku-B kwenzeka i-reduction. Ingakho mase kuhlangene kubizwa ngani nge-redox reaction. So i-reaction izongeza ku-A kuphela, so biza ngani nge-half reaction. It is and ku-B nakho kuzokwenzeka ibani u-half over another reaction. So half reaction kwi-oxidation, half reaction kwi-reduction iskiphela i-net redox reaction. Sekuhlangene i-oxidation ne-reduction at the same time. So makuthi sino A, for example, so to A has lost ama-electrons. Now, if A loses electrons, A uzosala nani no positive charge. Goba city 1, kusho ukuthi 1 electron have been lost. So this one is the oxidation. Let's see ambuga the B. The B here didn't have any electron. Here gain ama electron, so to B has gained, so the plus electron. Then skipela bani B minus. Right. So masipala kanje sotini ukuthi le reaction yenzeka ku A, it's the oxidation half reaction, a half reaction. Kanti ku B kwenzeka bani reduction half reaction. Reduction half reaction. So you have those two things that you need to consider. And oxidation half reaction mibhala kanjalo. Then uzobona ukuthi kuzobalula njalo, and kumbuzo bazokutshela write down the oxidation half reaction noma the reduction half reaction. Okunye fanele uqaphele ukuthi mobile reaction fanele ibalance in terms of number of electrons, iphinde balance in terms of charges. Ngoba masibuka ngala, i-charge on the left side is 0 ngoba this one is a neutral substance. Masiza on the right side A positive 1 can do E negative 1. So mohlanganisa lama charges akipela 0. So it means the charges are also balanced. In terms of electrons, sibona 1A here, corner nobani, 1A on the right side. So our atoms are also balanced. So we will be the same thing. Now one thing aga left, sino B on a charge of 0, then kono electron. So the total charge could be is negative 1 on the left side. Masi zangala, there is B minus. Na kona gutibani, negative 1. So the charge is also balanced. As the example is Caesar, ukuthi si understand kalula ukuthi masikhuluma nge oxidation or reduction suke sikhuluma ngani. Let's say for example sino chlorine, mhlambe sothi sino Cl2. Cl2 it is a chlorine. Charge yakhona is 0. Masothi ngoba i-charge yakhona is 0. What if this undergoes what a reduction? Chlorine undergoes reduction, it gains what electron. As long as it gains electron, so sotini plus bani plus E electrons. But uzibona ukuthi sinama electrons out 2. At the end ama element out 2. So bano Cl minus. Angithi beku 0 ngala. Then we have Cl minus because the chlorine has gained an electron. So masibuka kanje ini fanele siyenze, fanele si balance ama atoms. On the left side we have 2 chlorine, on the right side it's just 1. So kusho fanele balance is sifake bani sifake 2. Then the next thing fanele balance charge. Ama charges on the left side u 0 ngala, it's negative 1 ngala. So ngala on the right side, so no 2 times negative 1, so negative 2. See now, so no negative 2 on the right side, fanis balance ngala, so sfaga bani, sfago 2 ngala. At in that case, chlorine has chlorine is undergoing a reduction. It has gained an electron. This becomes what? A reduction half reaction. Right, so you just have to understand it ngaleyo ndlela. Then the other thing, sikhulume mhlambe any metal ezo undergo mhlambe i-oxidation. Let's say sine zinc. Now you have a zinc here. The zinc undergoes what? Oxidation. Oxidation. Most metals will undergo one oxidation. Now you have the zinc that is undergoing oxidation. It means zinc will lose electrons. So initially zinc will be just oxidation 0. At the end, zinc after losing ama electrons, so 2 plus. Lo plus uyasho ukuthi kushota ama electrons out 2. Then sote plus what? Plus 2 electrons that have been lost by that particular substance. So sinambani zinc 2 plus 2 minus. That becomes our oxidation half reaction. So yabona njalo mokuthi uzobhala i-reduction half reaction, ama electrons azoqhamuka ngaka left, on the left side. Right? Mawenza i-oxidation, ama electrons avela on the right side of the chemical equation. So just remember that. Mabukuthi kubhala ukuthi plus 2 minus, then this simply means ukuthi the substance inga undergo a reduction. But one substance, for example, it can undergo a reduction. It's all about oxidation. It always depends on the reactor, metal, which one is a stronger reducing agent, a stronger oxidizing agent. So what we're saying is this same zinc, the same zinc that we have here, kungenze go to this zinc also again ama electrons. Not to zinc again ama electrons. So but no zinc. Most of the times we go to zinc uzoba ushotela yini ama electrons, so it can be zinc 2 plus ezogena ama electrons out 2 message kipela bani zinc solid. That's so you have that. So you just need to understand ukuthi maubhala reduction half reaction or oxidation half reaction, you know what, and most of the time you need to balance ama atoms, also balance ama charges as well. Right. Now, transfer of ama electrons yenzeka ngendlela ezu2. One can be direct transfer, the other one can be indirect transfer. Direct transfer kusho ukuthi ama substance transfer ama electrons, they are in direct contact. But kungenzeka futhi ngoba sikhuluma ngama electrons ukuthi ama substances lawa exchange ama electrons our tintan like directly, but there is a medium through which ama electrons angahamba ngakhona. Let's take the situation where sina a cell or a container, kule container hlambe kunani kune copper sulfate. Copper sulfate. Copper sulfate siyazi ukuthi copper sulfate is a soluble salt. Copper soluble salt kusho ukuthi mase manzini as in an aqueous solution ezoskiphela ama ions. So you're gonna have CO2 plus ube nobani CO2 minus. Right, so sunama free ions. These free ions here, they can make the solution to be what? A good conductor. Right, it means when you're talking about the good conductor of electricity, then the solution so ibizangani nge electrolyte. An electrolyte is that aqueous solution that will conduct electricity or electric current due to the presence of free ions. The free ions will be CO2 plus, CO4 2 minus. Now, so ngoba sine solution it is copper sulfate. So siyazi ukuthi kule solution kuna ma ions o CO2 plus kuno CO4 2 minus maningi kule solution. Now what if manje sifaka zinc, a zinc metal? It's a zinc metal, yona, it's a zinc metal. So ngoba kwenzeka kanje uyabona ukuthi zinc unama atoms akhona, then they don't have neutral. The zinc metal is just neutral. Kodwa kule solution bona ukuthi copper 2 plus, copper ushotelwa ngani ngama electrons. Unabanu SO4 2 minus kule ion lena sothi bani no 2 minus kune excess of ama electrons. Obviously so understand ukuthi lama electrons are excess ku CO4 minus 2 minus avela kephi ku copper. Kusho ukuthi copper shotela ngani ngama electrons. Then ama atoms zinc alana azoyenza njani azomnika lo copper lama electrons ashodayo. Right, so the zinc that was there will do what? Will donate ama electrons kubani ku copper ngoba copper 2 plus. It's an ion. Mabu ion, it means ishotela mani ama electrons ngoba I positive. Kushota into a negative. So zinc, that is an atom, right, on the metal here. Yona in neutral. Kota njengoba kushota ngala, there will be a force of attraction. Izo attract ama electrons from a zinc metal. Means what? The zinc will lose ama electrons. And we say that a substance that loses electrons will be oxidized. So ngamanye amazwi the zinc after losing ama electrons izokhipha bani ama electrons out 2. Zinc 2 plus plus 2 E minus. This becomes what? Zinc oxidation half reaction yenzeka kephi with zinc. Now what will happen next ukuthi this copper angithi initially bengenawo ama electrons. Nanga ama electrons manje asuka kephi with zinc. So we have copper 2 plus. Copper 2 plus isuzowathatha now the C2 E minus. So the copper will do what? Will receive those electrons aqhamuka with zinc. So plus what? 2 electrons. These 2 electrons are available la ku zinc. So at the end ngoba copper yayishotela ngama electrons awu2 manje sewathole awu2 means copper izoba in copper metal. So we have the copper metal. In that case ngoba the copper ion received or gained ama electrons, then so the copper could is undergoing what? A reduction. So copper is reduced, copper is undergoing reduction. So copper ion is the oxidizing agent. Ngala fete zinc is losing ama electrons. This simply means that zinc is undergoing oxidation. This simply means that zinc is oxidized. This simply means that zinc is the reducing agent. So siyabona ukuthi the zinc reduced copper ion and the copper ion oxidized copper ibizwa ngani the oxidizing agent. The zinc reduced copper ion. That's why the zinc is called what? The reducing agent. So ngala so tisinani oxidation half reaction. Ngala sinani a reduction half reaction. So a redox reaction is over masihlanganisa lama half reactions awu2. So njengoba sibona ukuthi ama electrons awu2 ngala zinc lost 2 electrons ne copper yagena 2 electrons, so siyakwazi ukucancela these 2. So into sifanele sihlanganise manje the zinc on the left side of the equation sesele nobani no zinc plus into sele ngala sinobani Cu2 plus. Mese on the right side of 2 plus bani plus Cu. Right, now this becomes our net or the overall. The net or the overall redox reaction and sibalansile njalo. Sibalansile ngaleyo ndlela because suzobona ukuthi masibuka ama charges on the left side, asibuka ama atoms, there's one zinc gala khona no one zinc, one copper, so number of atoms balanced. Charges positive 2 ngala u0 la, so the total is positive 2. Masisa ngaka right positive 2 ngala u0 ngala, total is positive 2. So we have the charge, the net charge that is the same. Now ngoba sinale usothi bani sinani sesibhale I net redox reaction. At most of the time ufanele ube ready to understand ukuthi kungenzeka ukuthi uthole situation where copper for example ihambisana react noma uzinc react nani any substance, mhlambe yona leyo substance izokhiphela ama electron eyodwa kanti copper izothola mhlambe ama electrons awu2. right? So sobona ukuthi ungabalansisa kanjani, noma ube ne zinc ikhiphela mase reactor mhlambe nenye metal engaba mhlambe ion izothatha ama electrons awu 3. Right, let's look at scissor. Let's say sine aluminium as a reactor mhlambe ni sathi aluminium sibukuthi izo reactor mhlambe ne lead, with lead. Now into siyaziyo ukuthi i-aluminium, if it loses ama electrons ngoba ku group 3 izoba bani u3 plus. I-lead, if it loses ama electrons izoba bani uPb2 plus. That is the thing. Mase sebenzisa into sibiza standard reduction potential. This table here, this one will be very very important ukuthi ungakwazi ukuphendula wonke umbuzo on electrochemistry. This table here is very critical ngoba bakunika khona ama tables awu2 uzonikezwa wona kwipaper. There is table 4A khona no table 4B, so you have to choose one. When mawusebenzisa mhlambe kwi galvanic cell ungasebenzisa le, noma kwi electrolytic cell ungasebenzisa 4A, it's up to you. Manje ngifuna ukusebenzisa u4B, baluwe ukuthi table 4B. Kule table 4B uzobona ukuthi njalo makune table bakunika ama arrows akhomba indlela, like on this one. This one is 4A. Le arrow ikhomba iyaphezulu iyasho ukuthi increasing oxidizing ability. Lana ishone ezansi ikhombisa ukuthi increasing reducing ability. It means that ama substance wathola ngala ngaphezulu, right? If mhlambe ngifanele ngireact le substance ela nale engala, so yabona ke nje ngoba siya from the bottom going up, the substance it has what a higher or stronger oxidizing ability ngoba this arrow here ikhomba ukuthi as you go up the table kya increase any oxidizing ability. As you go down the table, it increasing what the reducing ability. Ngamanye amazwi, the substance that uzoyithola la phezulu, it's a stronger oxidizing agent, right? The one that you get at the bottom is a stronger reducing agent. Masithi this one is a stronger oxidizing agent, kusho it is what it will be reduced. Ngoba less it is a stronger reducing agent, kusho it will be reduced. The one at the bottom will be oxidized, right? Lana sikhuluma ngani nge-table 4A. Masiza ku table 4B is the same thing. So bona ukuthi bazokufakela futhi uline oyaphezulu ukhomba ukuthi as you go up there is an increasing what reducing ability. As you go up, increasing reducing ability. As you go down the table, there is an increasing what oxidizing ability. As you are increasing, and remember most of the times besikhuluma ngama particles out too, or element out too. As eyodwa izoluza ama electrons, eyodwa izowagaina ama electrons. So the one that will lose will be oxidized, the one that will gain will be reduced. So on this one uzobona ukuthi as we go up, ngikhuluma manje ngani table 4B. As you go up, it means what we are increasing what the reducing ability, or you have a stronger reducing agent. Kanti siyazi ukuthi a reducing agent is the substance that is oxidized, the one that loses ama electrons, right? So masibuga like manje sifuna comparisha aluminium ne lead. There is a between aluminium and lead. Ngithatha table 4B for example. Now if ngibona ukuthi which one between aluminium and lead will be oxidized, the first thing I have to do, I just need to check where is aluminium relative to lead. Itola phezulu kwi table, that means that one is a stronger reducing agent. Iona is over oxidized. This simply means iona is loser ama electrons. Can the one that I get at the bottom, right, simply means that one is a stronger oxidizing agent. So that one will be reduced. That one will gained ama-electron. So in our example, njengoba sifuna uku-react aluminium ne-lead. Aluminium, I think born from aluminium sithola la. Aluminium. This is table 4B, nanti aluminium, right? Aluminium sithola, nanti aluminium. Then as we lead, the lead is here, right? Yes. Once we totally lead, then everything is now simple. Now we are going to table here. As you go up, there is an increase in what? In the reducing ability. So means what? Aluminium is a stronger reducing agent than what? Than lead. Aluminium will be what? Oxidized. Lead will be reduced. So ufanele manje upale ini reaction. So if aluminium will be oxidized, so tini aluminium is oskipela aluminium ngoba oxidized means we lose what? 3 electrons. So we have what? 3e minus. That is the oxidation half reaction. Mese sibuga in lead will be reduced. So kana ngani nge lead 2 plus ezogena ama electrons out2 ukuze skipele bani lead. You have the lead that is produced. So we have the oxidation half reaction there and the reduction half reaction. Masibuga yokala as oxidation half reaction. Note in aluminium iota there's another aluminium. It charge is 0 plus 3 minus 3 also 0. So charge also balanced. Gala 1 lead, negative 2 minus 2, and here you have also 0. So you have that one. So this is your reduction half reaction. Manje fana senze njani sibhale net redox reaction. Right. Into siyaziyo ukuthi if aluminium donates 10, just an example, normal zoti donate 9 electrons. This simply means that lead now is receive abani 9 electrons. So uyabona ukuthi ngala akubalance ile ngoba from the reaction ama half reactions aluminium ukhipha 3 kodwa ngala khombisa ukuthi lead uthola bani uthola 2. So we must make sure ukuthi siya balance any lama number of electrons. So what we do in that case, so vele sithi u3 no 2 lana sesifuna bani LCM, the lowest common multiple between 2 and 3, that bani 6. So enzenjani the whole equation isizoyithi times 2. So ngala soba no 2 aluminium, sibe no 2 aluminium, u2 times 3 uzokhipela bani u6. Sesinama 6 electrons. Sifuna ukuthola 6 ngoba stay the LCM between the whole equation city times bani times 3. So soba no 3 lead ngala 3 times 2 or 6, yes, no 6 electrons, gala soba no 3. This one. So we are going to at the end, the number of electrons lost, 6 electrons, is equal to the number of electrons gained, 6 electrons. So into finally we understand ukuthi masina lokusho ukuthi manje siyakwazi ukancelisha le product. Now at the end ifanele sihlanganise ke manje ukuthi asibhale i-net redox reaction. So at that point, 2Al is from plus 3 is about 3Pb 2 plus. Mese loku kuskipela bani 2Al on the right side, 2Al 3 plus bani 3Pb. Equation lapo balance it. So we have what our net or the overall redox reaction, right? Ngifuna ukubuyela kule equation khona so that ngizokhuluma ngepoint eyodwa in terms of masithi zinc 2 plus ngoba 2 plus it's an ion, so it's not a solid. It is in an aqueous solution. It is in a solution. So ngale ndlela singothini kungenzeka ukuthi ngoba uyabona ukuthi ngesikhathi sithi it's an electrolyte uskipela SO4 2 minus. Uyabona ukuthi ngesikhathi sibalance bese ngawafakanga SO4 2 minus. Kodwa masibafaka futhi uzobona ukuthi kungenzeka ukuthi lo zinc njengoba sibhale kanje equation yethu zinc plus Cu2 plus vele uzobona ukuthi from the initial reaction kwaku zinc It was a zinc, a reactor nani, a copper sulfate. A copper sulfate. Right? So sulfate, zinc sulfate plus what? Plus copper. Right? Because this will be zinc plus what? Cu2 plus SO4 2 minus. On the other side, sinani, sino zinc 2 plus, ngoba manje zinc uhambisana no SO4 2 minus, plus SO4 2 minus, plus what? Plus Cu. So what do we need to check? Before the reaction, zinc uno 0 as a charge, akho lutho ngala. Ngala zinc sunobani suno 2 plus. So the oxidation number ka zinc isuke from 0 yaya ku positive 2. That means what? The oxidation number has increased. And if the oxidation number increases, means the substance is oxidized. Right? And if the substance is oxidized, it simply means it has lost electrons. Remember, negatively charged. So if you are losing that, you are likely to become more positive. Right? Masibuga I copper. Copper started with 2 plus. I shortela ngama electrons. But at the end, says copper or 0. So it started as positive 2, it ended as 0. So ngamayama zuguti copper has increased in terms of oxidation number. So oxidation number of copper has decreased from positive 2 to 0. And we know that if we define in terms of oxidation number, when the resistance is reduced. And if it is reduced, it means it gained electrons. Right? Mesesibuga ke SO4. SO4 u2 minus. Masiza ngala SO4 still what? 2 minus. Kusho ukuthi ku SO4 akwenzekanga lutho. SO4 2 minus did not lose or gain electrons. Ngamanye amazwi make sure ukuthi izinto zenzeka. So in that case sibiza ngani nge-spectator ion. So the SO4 2 minus is a spectator ion. Right? Ilapho nje una ku oxidation number ayishintsha kodwa zinc and copper the oxidation numbers did change. Right? So asubiyele lana ku direct transfer. Ankhuluma ukuthi transfer of electrons happens there as zinc is losing ama electrons. Right? So in that case, as zinc is losing ama electrons, then uyabona ukuthi directly ama electrons asuka ku zinc ayagepi ku copper ion. Right? Na kungenzeka ukuthi ngoba sikhuluma ngama electrons, ama electrons yakwazi ukuyihambela noma ngephi kuyintambo en electric conductor. So what if siya separate ke zinc nale copper ions? What will we get? Right? So in that case, so now we have a container, sibe nenye container ngala hlambe sina leo zinc, a zinc metal, ngala sibe nani sine copper, the copper metal. Then ngala sibe as electrolyte, ngala sibe ne copper sulfate as an electrolyte. Right? So when we say an electrolyte, kusho ukuthi ngala sinobani no zinc 2 plus, no SO4 2 minus. Ngala sino Cu2 plus, no bani, no SO4 2 minus. So what will happen is abatintan lab, but if we now connect fage a good conductor here, and this is kuluma transfer of electrons. We have our zinc here. Now it is in contact nani go Cu no Cu2 plus. Kusho lama electrons le atom elago zinc will lose ama electrons. Ama electrons azowenza njani? Azohamba ngala kule conductor. Ama electrons azohamba ngala. Right? Mehamba ngala ukuze kwenze njani ku copper ion. Ama copper ions will receive those electrons. Now because electrons are flowing through this conductor, the flow of charges. An electron is a charge. So the flow of charges represent what? A current. Then siya kipa bani skip a current. So siya faga bani ammeter no masinga faga voltmeter ngala. Right? We have what? An ammeter. So senze njani sinani sine electric current esi producing. So ngamayamaz we have created what? A cell. An electric cell or a chemical cell. Number from zinc to copper. ngoba siyabona ukuthi uzinc uzokhipha ama-electrons. Zinc will lose ama-electrons, but the transfer is not a direct one. Zinc is not directly connected to copper, but it will go through via the conductor. And if there is a flow of electrons in a conductor, then we have what? An electric current. Now, so singathini ukuthi this electric chemical reaction enzeke lana has produced what? A current. So singathini there is a conversion of chemical energy. We have converted a chemical energy into what? Into electrical energy. Conversion of chemical energy into electrical energy. Lento sibiza ngani? Ke galvanic cell. So we have a galvanic cell. The galvanic cell is just that electrochemical cell that will convert chemical energy into electrical energy. And you understand ukuthi lokhu kwenzeka kanjani. Now, what will happen when the reaction? Remember, the reaction takes place between zinc and copper, and the reaction yethu isakhona as the net redox reaction still here. Our reaction is still here, so we don't need to forget that. Zinc is a solid, lana aqueous solution. Zinc will be now aqueous solution. Low abe is solid. So in that case, we have this chemical reaction that has taken place. Kodwa ekugcineni siyabona ukuthi sithola bani ama-electrons. Those electrons produce what? Electric current. So a galvanic cell yenza njalo. It convert what? Chemical energy into electrical energy. So that's what you need to understand as the basics of electrochemistry. Now, asibukeke le cell yethu kahle sesiyazi manje sesikhuluma ngani nge-galvanic cell. Right? Ngoba sikhuluma nge-galvanic cell, let's look at a situation where we have the same one. We have our electron or zinc 2 plus, no, SO4 2 minus. Remember, SO4 2 minus ama spectator ion. Then sino copper ngala, this one is zinc. Sino copper ngala, because we have a copper, then we have copper ion and SO4 2 minus. Now we have our current that flows there in the outside. On the outside, so we have electrons. Into siyazi ukuthi ama electrons asuka kwi zinc because zinc is losing ama electrons, so in direction ihamba ngala, right, from zinc to copper. Even if we could put zinc ngala, ama electrons azosuka ngala kwi zinc ezengala. So what happened to zinc? Zinc is undergoing what? Oxidation. So oxidation yenzeka kule. Now le part lezo siconnectela ngani sibiza ngani an electrode. Electrode. Nala futhi, we have also an electrode. Manje lama electrode out awafani ngoba kule electrode yokuqala kwenziwa ini? Kwenzeka oxidation. Kanti kule electrode yesibili kwenzeka kule electrode kwenzeka khona oxidation. Le electrode sibiza ngani? Anode. Le electrode la kwenzeka khona reduction sibiza cathode. Right? Ngoba sikhuluma nge-cell, negative electron. Ngala we have what? A positive electron. Ama electrons asuka ngala kwi anode, aya gepi kwi cathode. So that's what you should understand. Now, asibukeke one more thing. As ama atoms with zinc are release ama electrons, akusiyona ama zinc atom or zinc metal, they become what? Or zinc 2 plus. Zinc 2 plus. Uzobona ukuthi as the reaction progresses, so kipela bani o zinc 2 plus abaningi bayangena kule solution. Kanti o SO4 2 minus. Yabo to SO4 2 minus bona aba increasing ngoba vele ama spectator ion. So the solution yakho at the end it's getting positive. And uzobona ukuthi kule metal iyancipha ngoba every time ama atom asuka ngala kule metal iyancipha in terms of size. It means even the mass of this anode is doing what? Is decreasing. Mesiza ngala kwi cathode, right? Uzobona ukuthi every time uzongala istake kugepi kule electrode. So at the end uzobona ukuthi the mass of this cathode yenze njani iya increase. Now as it's going there, ama-copper ions in this solution ayancipha ngoba most of copper ions are becoming what? Ama-copper atom. So at the end, the solution will become what? Negative. O-SO4 2 minus bazoba baningi kule solution ngoba sisebenzisa initially besiqale ngam-OCU2 plus balingana no SO4 2 minus. Manje masebenzisa o-CO2 plus uyabona o-SO4 2 minus baningi kule solution as compared, so the solution is getting negative. Ngala we had same number of zinc ions and same number of SO4 2 minus ions, so the solution was initially neutral. Ngoba sikhipha o zinc 2 plus, so the solution is getting what? Positive. Now ama solutions zethu ama electrolytes awasekho neutral, so to maintain neutrality sifaka i-element esizoyibisa ngani? Nge-salt bridge. Sifaka bani? U-salt bridge. Salt bridge izokunika mani ngoba sikhuluma nge-salt, let's say ngithatha KNO3 potassium nitrate. Masisi break down potassium nitrate sikhiphela bani? OK plus no bani? NO3 minus. So attract ngala ku zinc half cell. The positive ones will be attracted kule half cell ngoba this solution is getting negative. So the role of the salt bridge, one is suyabona ke circuit is completed. The second one is the salt bridge is to do what? To maintain the neutrality of the cell, right? Yeah, so that is just a few things that finally understand in terms of electrochemistry, right? So we are speaking next time you Google electrochemistry.
Siyathemba nifunde kahle nasithokozela isifundo sethu sanamhlanje.